Bismillah, right? Okay, guys, we were talking about the center of mass. While finding the center of mass, we have seen how to find the center of mass of a rod when you have simply a rod here. Okay, so uh, when there are um, different masses at different distances over here. So, like we have used the formula that the center of mass is going to be m1 x1 plus m2 x2 so on over m1 plus m2 plus m3 so on. That is how you were finding the center of the mass of a rod. Okay, then we moved on to the two-dimensional uh, situations here. Like if you have let me take you to that situation so that I can recap that quickly. Okay, uh, we were here when we were finding here the center of mass for something like this. Okay, so here you divide this situation into two parts because it is a two-dimensional situation. Like you have a Cartesian plane over here, so the center of mass will not just be one point. Like if this is the point of reference over here, so this is suppose A. So you were determining the center of mass from this point somewhere over here, where all the mass is supposed to be acting over here. Okay. So when you have this two-dimensional shape over here, guys, so the center of mass has to have the x coordinate and the y coordinate. So, for example, if you look at this situation, when you want to find the x coordinate of the center of the mass, so that would be found through this. You see that this is 2g over here. This is 4g over here. This one is 4g here, and this one is 5g over here. And just see that what is the x coordinate for these points where these weights are being applied over here. Now for this, at the point O, the x coordinate is 0. So its moment is going to be 2g times 0. Okay. This one, this 4g over here, this has an x coordinate which is 4. This is going to be 4 times 4g. Similarly, this 4g over here also has the x coordinate 4. This is 4 times 4g. Plus this 5g over here, it has the x coordinate which is going to be 0. So this is going to be 0 times 5g, and that is equal to sum of all the masses, like as the formula suggests here, the sum of all the masses is 2 plus 4 6 plus 4 10 plus 5 15. So this is going to be 15g times x over here. So this way you get to the x coordinate of the center of the mass. That is, you can see it is written here, that is 32 or 15. Similarly, when you want to find the center of mass as y coordinate, so you see now this 2g has a y coordinate which is 0, 2g times 0. This 4g wala force also being acting at a point where the y coordinate is 0, then plus this 4g, now the y coordinate is 2, and then plus this 5g times 5, and that is equal to 15gy. And this way you get to your y coordinate, that is going to be 1.2 meters. Okay, so you start from a rod, and then now this is basically a framework. Okay, this is a framework. This is not a 2D a rectangular region over here. This was just a framework. Okay, so next we move on to, like we have discussed all this example. You can see its solution here. Okay, we have tried all the parts. Okay, now after the framework, we move on to the lamina. Okay, the lamina is a two-dimensional shape. Okay, and this is if a lamina is described as uniform, then we assume, this is a very important information here, that its mass is spread evenly across its area. So when we talk about the lamina, then we must be able to first of all find the total mass of that lamina, the total mass of lamina. Once you know the mass, because in all these examples we were able to determine the center of mass because we knew the masses being applied at different points. Okay, so when you have to have when you want to find the center of mass, you must know that what is the total mass. For that purpose, you will be given uh, the mass per unit, which is known as rho over here. Okay, this rho means the mass per unit. So as an example, we have tried, for example, look at this rectangle. Suppose this is its length is 5 centimeter and its width is 2 centimeter, and we're given the rho that is let's say this is 5 grams per centimeter square. Very thin lamina here. Okay, so we want to find that what is the total mass of this rectangular lamina. For that purpose, you will have to find its area. That is 10 centimeters square. The total mass, therefore, would be 10 times this 5 grams. So that is the total mass of this rectangular lamina is going to be 50 grams. So if you have this rho, that is the mass per unit, and you have the area, you can determine the total mass. In these questions, in your further mass, you will be given this mass per unit as rho, 2 rho, 3 rho, half rho. So you will have to write the total mass in terms of rho. For instance, instead of this giving this 5 gram per centimeter square, you were given that the it is just rho is this is rho over here. Then the total mass would be 10 rho. Okay? So you will have to write this in terms of rho over here. So I have told you briefly how to find the mass once you are given the mass per unit, and you can determine the area of that lamina. Acha, when we talk about the laminas, first of all, we go into the rectangular laminas. For a rectangle, the center of mass is the center where the lines of symmetry meet. For instance, there is a rectangular lamina like this. Suppose this is 10 cm, this is 6 cm. So the center of mass would be acting at this point, which is 5 cm from here and 3 cm from here. That is how you determine the center of mass of a rectangular lamina. When you have a triangular lamina, the rule is quite simple. If you have the coordinates, like suppose this is x1, y1, this one is x2, y2, this one is x3, y3. The center of mass for a triangular lamina is going to be x1 plus x2 plus x3 over 3 comma y1 plus y2 plus y3 over 3. Through this formula, you determine the center of mass for a triangular lamina. Okay, so for the rectangular lamina, it is simply the center. For triangular lamina, this is 1/3 of the sum of all these x coordinates, comma 1/3 of the sum of all the sum of all the y coordinates. Then we come across the sector, a lamina which is in the shape of a sector. So for that purpose, you just need to remember that the center of mass of a sector is going to be from the center. This will be this much from the center. Okay? So look at this, the center of mass of a sector shaped lamina with angle 2 alpha. Now, whatever the angle is given to you, you will assume that to be 2 alpha. For example, if there is a quadrant like this, so you will start saying, okay, my 2 alpha is 90 degrees, or that is, we should keep that in radians here. So that is 2 alpha is pi by 2. Okay, so when you want to find the center of mass from this over here, you should draw this line here. Okay, so this is the center of this mass here. So that would be using this formula 2r sine alpha over 3 alpha. You can determine the center of mass of this lamina, which is in shape of a sector over here. Once you have determined this OG, and suppose you have to determine the x coordinate and the y coordinate of this center of mass, you will have to apply your trigonometry over here. Let me show you, give you an example here. Suppose here is this question, guys, and you want to find the center of mass of, suppose this one, let me enlarge this. Now, using the formula, we have already determined that the center of mass is going to be this 4r under root 2 over 3 pi, because this is the formula that we use here. Guys, again see that this angle of the sector is pi by 2, and we have used this, we have kept this pi by 2 equal to r2 alpha. This is your pi by 2. Therefore, your alpha is going to be pi by 4. So putting alpha into this formula, you get that this is 4r under root 2 over 3 pi. But suppose we want to get that what are the coordinates of this center of mass over here. Then you will have to use a bit of trigonometry over here. If this is your x, this is your y, this is your alpha over here, and you have got this OG. Let me just write this OG over here for a moment. This x would be OG cos alpha, and this y would be OG sine alpha. And you know that cos alpha is 1 over under root 2. Like if this alpha is pi by 4, so this will be 1 over under root 2. So if you multiply this by 1 over under root 2, because you know your cos alpha, cos 45 and sine 45, they are both equal to 1 over under root 2. This way you have the same x and the y coordinates here. So this g then has the coordinates 4r over 3 pi, comma 4r over 3 pi, assuming this O to be the origin over here. Here guys, if you look at this example here, in this where you have a semicircle here, and you're determining this from this O, obviously this 4r over 3 pi is going to give you, this is simply 4r over 3 pi comma 0. If you assume this O as the center of, I mean this as origin over here, and then the center of mass will have the coordinates 4r over 3 pi comma 0. I'll keep it up to this. Inshallah, in the next class, we'll be going into the combination of different laminas over here. Okay? So try to reinforce, try to memorize the formulas for the center of mass of a rod, for a framework, for a triangular framework, for a, for a not triangular framework, for a rectangular framework, and then the rectangular, triangular, and sector shaped laminas. We shall continue from this, inshallah, in the next segment.